very good morning to all my students. We met before and we learned about a little bit about valencies, about formula making, and about the important chemical compounds which we are going to study this year. Now, let us proceed further in the chapter, chemical reactions. So, as the name of the chapter states, chemical reactions. My dear students, how do we come to know whether a chemical reaction has taken place or not? So there are 4 symptoms which tell us whether the chemical reactions have taken place or not. The first one out of them is whether there is a change of state or not. The second one is whether there is change in temperature or not. The third one is whether there is evolution of some gas or not. And the fourth one is whether there is any change of color or not. So let us jot them all one by one and understand them in detail. So the first one is change of state. For example, let us take the example of burning of magnesium ribbon. So we all have read in the previous classes that whenever the magnesium ribbon burns, it burns with a dazzling white flame and gives a white ash. So what kind of chemical reaction is taking place there? So whenever any kind of burning is taking place, it takes place in the presence of oxygen, isn't it? So whenever magnesium is going to react with oxygen, it is going to form MgO. And MgO is a white powder. Remember, magnesium was a silverish grey ribbon. When it burned, it gave a dazzling white flame and a white powder of MgO. The most important thing in this chapter is the observations. So what is the observation of this? That you get what? A dazzling white flame and a white powder. The second symptom of chemical reaction taking place is the change of temperature. So the first one was change of state and the second one is change of temperature. In the important formulas, we all jotted down the formula of quicklime. So what is the formula of quicklime? It's CaO. What is CaO? Chemical name is what? Calcium oxide. And the common name is what? Quicklime. So whenever we put water over quicklime, the other day also we discussed, we get what? Slaked lime. And I told you all, the chemical name is calcium hydroxide. And the observations in the above reaction are, there will be a hissing sound. There will be what? A hissing sound. Second, there will be slaking of lime taking place. Slaking of lime, what do we mean by slaking of lime? मतलब जो lime का lump था वो बिखरना. So that process is called what? Slaking. So slaking of lime takes place. And the third one is what? It's an exothermic reaction. So you can see bubbles in the bucket or whatever container the reaction is taking place. Bubbles in the container because of the fact that it is a exothermic reaction. So we'll just go through this once. Chemical reactions take place and they give 4 symptoms. What are they? First, change of temperature. Second, change in state. Third, evolution of gas. And fourth, change in color. Out of these 4, we have discussed what? 2. So the first one is change of state. For example, magnesium ribbon burning in the presence of oxygen and giving a white powder. So what are the observations? Dazzling white flame and a white powder of magnesium oxide. Next is change of temperature. We took what? Quick lime, poured some water over it, the lump of the lime slate, and it formed slate lime. And the chemical formula of slate lime is CaOH whole twice. What are the observations? Hissing sound occurs, slaking of lime takes place, and the bubbles in the container take place. Now let us do a little bit about the applications of this slate lime. Slate lime is the material used for whitewashing. So generally what have we observed is after 2-3 days of whitewash, we can see a shiny white finish on the walls. Can you all tell me the reason of this shiny white finish? The reason is that this slate lime formed reacts with the atmospheric carbon dioxide. It reacts with the atmospheric carbon dioxide to form CaCO3, that is calcium carbonate, plus water. Calcium carbonate is also a form name of limestone or marble. So marble has a shiny white finish, and because on the walls calcium carbonate is formed, so we also see a shiny white finish after 2-3 days of whitewash. This is also, we also did it as a test of carbon dioxide. Remember we did 3 tests of carbon dioxide. First, it comes out with a brisk effervescence. Second, it extinguishes the burning candle. And the third is that whenever you pass carbon dioxide through lime water, it turns it milky. And what was lime water? A dilute solution of slate lime, though both of them have the same formula. So I hope I'm clear up to now. So now let us move on to the third point. Third, we are going to discuss evolution of gas. In evolution of gas, we are going to discuss 3 examples. First, for example, if we pour some zinc granules in dilute sulfuric acid solution. So what was the formula of sulfuric acid? H2SO4. So when zinc reacts with H2SO4, ZnSO4 is formed and H2 is released. Okay? So second is the evolution of gas, and what does it say? When lead nitrate is heated. So what is formed? PbO plus NO2 plus O2. These two are the gases. Upward arrow we show for the gases, and the upward arrow is here for nitrogen dioxide, and it gives out brown fumes. Remember, we noted down in the color that NO2 shows what? Brown fumes. Next is FeSO4.7H2O, which is green in color, gives FeSO4 plus 7H2O. Remember, this was water of crystallization, which was imparting this green color to FeSO4. When you heat, the water of crystallization evaporates, and what happens? This turns what? White. On further heating, what happens? Fe2O3 plus SO2 plus SO3 is formed. So here again 2 gases are evolved, and this is reddish brown color. Remember, we learned it for rust, and SO2 and SO3 are gases which give burning, rubber, like smell. Is it okay? I'm repeating myself again. We are going to do 3 examples for evolution of gas. The first one is whenever we pour zinc granules in dilute H2SO4 solution, what do we get? We get colorless solution of ZnSO4 and bubbles of hydrogen gas. If we heat a white crystalline salt, all the solid salts I told you are white crystalline, just like our common salt which we use in day-to-day life. So if we heat, dry heat, it's not an aqueous solution, it's a solid white powder. If you dry heat, what happens is it gets converted into PbO, NO2 and O2. And you can see the brown fumes of NO2, as well as whenever a dry salt is heated, some residue is left behind and it is a yellowish brown residue. So these are the observations which we need to keep in mind. White crystalline salt on heating gives a yellowish brown residue, brown fumes of NO2 plus O2. Another example is when a green color, this salt again is a solid salt. It's not an aqueous solution, it's a solid salt. So green colored salt, FeSO4.7H2O, when it is heated, FeSO4, white colored salt is formed because it loses its water of crystallization. On further heating, it changes into Fe2O3, that is reddish brown colored residue, and burning rubber-like smell of 2 gases, that is SO2 and SO3. So now let us come to the last topic of the day, that is change of color. See, there is a very fine hairline difference between what is a precipitate and what is a residue. Whenever 2 aqueous solutions are mixed and some semi-solid residue settles down, it is called a precipitate. But whenever any dry salt is heated and some solid residue is left behind after few gases escape, it is called a residue. So up till now we were heating dry salts when we were studying about evolution of gas. Now as we are talking about change of color, we will be mixing 2 aqueous solutions and seeing whether there is any change of color or not. So the next is change of color. Can anybody recall and tell me what was the color of solid lead nitrate? The color was white. But if you make an aqueous solution of solid lead nitrate, if you write AQ here, we mean it's an aqueous solution, and mix it, this aqueous solution is colorless, and mix it with aqueous solution of another salt, that is potassium iodide, which is again a white solid crystalline salt, and the aqueous solution is colorless. Both of them when mixed, they form a semi-solid residue, just like curd, Immediately within fraction of seconds, when you mix both of them, a white semi-solid substance settles down. And this is called yellow, PbI2. We show it by a downward arrow. As we showed gases by an upward arrow, PbI2 is shown by a downward arrow. Precipitates, are shown by a downward arrow. And what is the color of the precipitate? It is a yellow PBT. And the second compound which floats above is potassium nitrate. So I'm repeating myself again. What is happening? Aqueous solution of 2 salts are taken. So what is the color? Both of them are colorless. Okay. When they were mixed, they crisscross and react, and they form a yellow precipitate of PbI2 and KNO3. Okay, so this reaction is change of color, and this is all for today.